today's new definition, new topic. Yes, very important event. Very important. Probability, random experiment, then sample space, then event. Very important. Yes, I would say one of the example, random experiment. Tossing a coin once. S is equal to head appears, maybe tail appears. S means what? Sample space. Yes. Therefore, what is the value of n of s? 2. That's right. Now, coming to the event now. I will take one example here. Getting head. Getting head. Yes, from this, getting head. Head means we have only one option. Head will turns up. Head will turns up. Or head face must be top. So among these two, which is head? Yes, head. Consider only head. Don't consider T. Why? Because you see the example here. Getting head. Getting head. Head. So H is also one of the sample point or one of the element present in the S also. Correct? Which means that as this is subset of sample space. Correct? Yes. Therefore, subset of a sample space is called event. Yes. What is the meaning of event? Subset of a sample space. Subset of a sample space is called an event. Please don't neglect. Note down all these definitions. Subset of a sample space. Not only this one, all the subset you can say, no problem. All the subset of a sample space is called event. So generally, events are generally denoted by E1, event number 1, event number 2, E2, event number 3, event number 4, and infinite. So getting head, this is the description. Therefore, getting head is one of the subset of the experiment or subset of this sample space. Yes, HT. So HT, these are the two possible outcomes of a random experiment, that is tossing a coin. So you see one by one here. This is random experiment. So this is yes. Yes, this is subset. Subset is called as event. You see one by one how related these definitions are. If you know random experiment, then you can write yes. If you know yes, then you can write the events. So this is event number 1. Getting head is one of the description of this random experiment. Right. Yes, similarly write one more, another one. Getting a tail. Let's call it as E2. What you will write now? You only consider this one. Consider always while you are writing events, you consider only sample space. Yes, select tail means ST. Yes, similarly here write, no problem. This is E1. Yes, what is the value of E1? I told you N of E1 means total number of elements present in the set E1. How many elements are there? Only one. Only one possible. Getting head only one. Other than this, you don't have any option. Yes, here. What is the value of N of E2? Total number of elements present in the set E2. That is N of E2. Only one. That is T. T correct. But how many means E2 T? N of E2, that is 1. Yes. Can you write? Number 3, S itself. Itself is also one of the element. S number 4, null set. That's very important. So because every set is subset of itself and also null set or empty set, is also subset of itself. As these two, don't forget these two, this is very important. Every set is subset of itself. So S itself is subset of S only, and null set is also, or empty set is also subset of itself. Correct? So this is very important. So totally how many events are there? 1. So this is 3, 2, 3, 4. Correct? So these are only 4 events can be read by using this random experiment. So there is a formula. Now you see, I told you how many elements are there in this sample space 2. So the formula is 2 power n. So 2 power n means total number of elements present, or total number of possible outcomes. 2 power 2, that is 4. Can you say now 4 means getting it is 1, getting tail is another 1. So this is very important. Itself, I mean S itself is a subset of S, and finally null set. So what is the meaning of event now? So event means all the subset of a random experiment. All the subset of a random experiment, which means that S, I mean sample space. All the subsets of the sample space is called as event. All the subsets, including null set and itself. Suppose take another example here. Example number 2. A die is thrown. Yes, can you write yes? A die is thrown. Possible outcomes 1, 2, 3, 4, 5, 6. So what is the value of n of s? 6. Don't think 6 is maximum here, not like that. Count how many are there? 1, 2, 3, 4, 5, 6. So I told you this is the formula to find the total number of events. I mean total number of subsets. Subset of a sample space, nothing but events. So 2 power n, 2 power 6. 2 power 6 means you should multiply 2 6 times. 2 into 2 into 2 into 2 into 2 into 2, 2 into 2, 4, 4 to 8, 8 to 16, 16 to 32, 32 into 2, 64. Yes, 64 events you can write by using this random experiment, that is a die is thrown. In this 64, yes, very important, as itself, I mean S is included here, and another one as null set is also included here. Itself and null set, these two are included here. Remaining 62 you can write easily. So can you say at least one event? Yes, E1 from this random experiment. Getting even number. Getting even number, write one by one. 2, 4 and 6. As 2, 4, 6 also present yes. Therefore this is subset of S. This is subset of S. Therefore this is called as event. S. Perfect square 1, 4. Odd numbers 1, 3, 5. You can write, I told you no. So 64 events can be right by using this random experiment. So description of this random experiment is a die is thrown. A die is thrown. Okay na? So what is the meaning of event? So event means subset of all the subsets of a sample space is called event. All the subset of a sample space is called as event. So general events are denoted by generally E1, E2, E3, E4 you can write. So this is the formula to find the total number of events. 2 power n. N represents total number of possible outcomes in the sample space. So if 2 is there, 2 power 2, 4. So 6 means 2 power 6, that is 64. So this is about event. So next definition we will discuss next class. Please don't neglect all these definitions. Okay na? Please go through it one by one. Be perfect all these definition. Daily I will repeat because of your purpose. So get ready for another class. Learn all these definitions: probability, random experiment, sample space, event. So some definitions are remaining. We will discuss one by one in next classes. Okay. So since from 3-4 periods we are discussing about one of the very important chapter, that is probability. So what we have discussed already, just I will write all the points. First one, what is the meaning of probability? First point, probability is a branch of mathematics, deals with study of uncertainty by mathematics. Study of uncertainty by mathematics is called probability. Now second one, random experiment. An experiment is said to be a random experiment. It satisfies two conditions. Condition number one, it has more than two possible outcomes. More than two possible outcomes. And condition number two, it is not possible to predict outcome in advance. We cannot tell, we cannot say outcome in advance. We cannot predict the outcome in advance. Next definition, very important, sample space. Sample space is the set that consists of all the possible outcomes of a random experiment, and it is denoted by letter, capital letter S. Very important. Fourth definition, that is event. All the subset of a sample space is called an event. So generally events are denoted by E1, E2, E3 and so on. So there is a formula to find the total number of subsets or total number of events, that is 2 power n. So n means total number of possible outcomes in the sample space. So total number of possible outcomes in the sample space, that is n. So all these points we have discussed in previous classes. Now another very important, occurrence of an event. Next point, occurrence of an event. Please note down all these definitions by using a blackboard, what I explained, or by using textbook. Why? Because the complete exercise depend upon all these definitions. I told you already, nothing calculation in this lesson. Very simple calculations are there, but all the answers depend upon the definitions or basics. Now, occurrence of an event. Event, as you know already, subset of the sample space. Subset of the sample space is called an event. Yes. Now, what is the meaning of occurrence? When the outcome of a random experiment satisfies, when the outcome of a random experiment satisfies the condition mentioned in the event. Condition mentioned in the event. Very important. Condition mentioned in the event. This is very important. When the outcome of a random experiment satisfies the condition mentioned in the event. Condition mentioned event or condition mentioned in the event. For example, as tossing a coin once. Tossing a coin once, as you know already, head appears or tail appears. So this is denoted by S. So total number of possible outcomes, that is 2. So total number of events, 2 power 2 is equal to 4. Now you see, occurrence of an event. Condition mentioned in the event. So I will consider one event. So generally I told you, events are denoted by E1, E2, E3, E4 and so on. Now I will say one event here. I will say one condition is say, yes, head, getting head. Getting a head. Our topmost face appears head. Now as E1 is equal. From the sample space, we have two options, head or tail. So what is the description or condition mentioned? What is the condition mentioned here? Getting a head. This is the condition. So condition is also called as description of the random experiment or description of the event. So getting a head, you have to select only head. Yes, right, only head. So this result satisfies condition mentioned in the event. What is the condition here? Getting head. Getting head means yes, head. We have only one option. Okay, so therefore this is called as occurrence of an event. Yes, what is the meaning of occurrence of an event? When the outcome of a random experiment. So this is the random experiment. What is the description of this one? Tossing a coin. Yes, this is an example for random experiment. Yes, that is the sample space. Number of possible outcomes, head or tail. Total number of possible outcomes, 2. Total number of events, 2 power 2, that is 4. I will consider one event. So condition mentioned or a description of the event. Getting a head, condition mentioned in the event. So getting a head is example for event. What is the condition mentioned in this event? Getting a head. This is the condition. Now from this sample space, what possible outcome satisfies? What possible outcomes satisfies this condition mentioned, that is only head? Yes, I will write suppose T. So is this following this condition getting head, this possible outcomes satisfies this condition mentioned getting head? Is it possible? No, this is wrong. So this is only the result satisfies this condition mentioned. So this is called as occurrence of an event. Yes, what is the meaning of occurrence of an event? When outcome of a random experiment satisfies the condition mentioned in the event. Suppose if you want to take one more example. Yes, what is the condition here? Getting a tail. Yes, this is the condition mentioned. Or description of an event. Yes, now this is E2. From the sample space, select the possible outcome which satisfies this condition. So this is the possible outcomes satisfies this condition mentioned. So therefore this is called occurrence of an event. Next, E3. Head and tail appears at a time. Is it possible? Head and tail appears at a time. No, this is impossible. Null set. In yesterday's class I told you null set is also one of the subset. Next, event number 4. The condition is head appears or tail appears. Nothing but the sample space. So these are the 4 events what I told earlier. Okay, so these are called as occurrence of an event. Yes, E1 is equal to head, getting a tail. So this is called occurrence of an event getting a head. Occurrence of an event getting a tail, that is E2 is equal to tail. So occurrence of an event, the condition is head and tail appears at a time. So this is condition is head and tail appears at a time. This is the condition. Yes. So null set satisfies this condition. So we cannot get both phases at a time. So null set satisfies this condition. So what about this kind here? Head appears, head or tail appears. So this is a condition mentioned. So H or T satisfies this condition mentioned in the event. So these are all called event. Getting a head, event. Getting a tail, event. head and tail appears at a time. This is also one of the event, but this is not possible. Head or tail appears. So these are all condition mentioned. As occurrence, occurrence means H for this one. Second one tail, null set, HT. So these are all called occurrence of an event. As I repeat last time, when the outcome of the random experiment, satisfies the condition mentioned in the event, then we can say that occurrence of an event. Then we can say that event has occurred. So getting a head, this event has occurred. So getting a tail, T, event has occurred. Head and tail appears at a time. Yes, null set, event has occurred. Head or tail appears, H or T, event has occurred. So this is the meaning of occurrence of an event. When the outcome of a random experiment satisfies the condition mentioned in the event, we say that event has occurred. Is it clear? Okay, na? Right. Next one. Next definition, note down, favorable outcomes. Favorable. Next one, favorable outcomes. So just now what we have discussed, occurrence of an event. Why I am repeating all this, I told you. So definitions are very important. Now occurrence of an event over. Now coming to next one, favorable outcomes. Yes, what favorable outcomes means? Very simple. The outcomes which ensures the occurrence of the event are called favorable. For example, again, as throwing a die once, as throwing a die once. This is example for random experiment. As a sample space is denoted by S. What are the possible outcomes? 1, 2, 3, maybe 4, maybe 5, maybe 6. So these are the possible outcomes. What is the value of N of S here? 6. Total number of events? 2 power 6. 2 power 4, 16. 2 power 5, 32. 2 power 6, 64. Here S is also included and null set is also included. This is very important point. Don't forget. Next, favorable outcomes, throwing a die once. Now I will say some examples. Some events I will consider. Some events now. For example, as getting a even number. Getting a even number. Getting a even number. So this is a condition mentioned. Condition mentioned or description of an event. Both are same. Condition mentioned. What is the condition mentioned here? Getting a even number or description of an event. Yes, please note down what are the possible outcomes. From the sample space, yes, select only even numbers. Yes, 2, 4, 6. Yes, 2, 4, 6. Is there any? No. These only 3 possible outcomes are possible. If you are, you can take another one. So, E2. Getting a prime number. Yes, getting a prime number. As E2 is equal to prime numbers, the numbers which are divisible by only 1 and itself. Only 1 and itself. Then it is called as prime numbers, or a number which has only 2 factors. 1 and itself. As getting a prime number, select 1 by 1. 2 is only the even prime number. Then 3 is also prime number. Yes, then 5 prime number. Okay, na? So getting a prime number, this is description of an event or condition mentioned. So what are the possible outcomes that satisfies this event. 2, 3 and 5. Yes, this set is called as favorable outcomes. Favorable outcomes. So the outcomes, who is one of the outcome? 3 is one of the outcome, 5 is one outcome. The outcomes which ensure means only these three possibilities is possible. Only these three possibilities are there getting a prime number, which ensures the occurrence of an event. Occurrence of an event, then it is called as favorable outcomes. Favorable outcomes to that event. Yes, getting a even number 2, 4, 6. So these three possible outcomes ensures that occurrence of the event getting even number. Only these three are possible. Even number, only these three are possible. No other than these three numbers possible or satisfies this condition mentioned, that in even number. So 1 is odd, 3 is also odd, 5 is also odd. This is only the result. Only three possible outcomes are there favorable to this event. So similarly here also 2, 3, 5. Yes, therefore these two, we can write many examples like this. So this is the favorable outcomes. Okay, is it clear? Yes. What is the meaning of favorable outcome? The outcomes which ensures the occurrence of an event. Which ensures the occurrence of an event, then it is called as favorable outcomes of that event. If you want, we can consider some more examples. No problem. Okay, na? Yes. For example, yes, tossing 2 coins. Tossing 2 coins. I will give one more example for favorable outcomes. As sample space, both times head appears, first time head, next time tail, first time tail, next time head, both times tail. So this is the sample space of the random experiment tossing 2 coins. Thus total number of possible outcomes n of s 4. Total number of events 2 power 4, that is 16, including s, and here also null set is included. Next, I will consider some events now. E1, getting 2 heads. Getting 2 heads is equal to h. Correct? Yes, this is only the possible outcomes. This possible outcomes ensures, correct? This possible outcomes ensures, very important, the occurrence of the event, that is tossing 2 coins. This is only the possible outcome. This is only the possible. TT means this is wrong. That is not favorable to the this condition mentioned or this event. Okay, na? Suppose exactly 1 head. Yes. Second one. Exactly 1 head. Yes. What are the possible outcomes? HT, even TH is also possible. Only these two results or these two possible outcomes which ensures this event satisfies or occurrence this event, that is exactly 1 head. So these two results ensures this event, therefore these two possible outcomes, favorable outcomes of the condition or event, that is exactly 1 head. So this is the meaning of favorable outcomes. Okay, is it clear? Okay, right. Next, what I have discussed just now, favorable outcome. Next, equally likely outcomes. Equally likely outcomes. Another very important, equally likely outcomes. simple, equally likely outcomes. As for example, consider a random experiments. Tossing a coin once, head appears or tail appears. Only these two are the possible outcomes if a coin is tossed once. Example for random experiment, this is S denoted by sample space denoted by S. Now consider one by one event. Event number 1, getting a head. Yes, can I say what is the possible outcomes? Head. Next, E2, getting a tail. Possible outcomes only T. Correct? Yes. If a coin is tossed, it is equally likely. Why it is called equally likely means getting a head we have only one option. Getting a tail is also only one option. Either head will turns up or tail will turns up. Either head or tail up. Therefore, it is equally likely. Equally likely. Is it clear now? Why? Because why it is called equally likely? We have only one option. Either head turns up or tail turns up. Then it is called as equally likely. Here also only one result satisfies this condition. Here also only one result, that is T, satisfies this condition. Therefore, getting head and getting a tail is example for equally likely. If you want, you can consider one more example. Example number 2, throwing a die. As first note down sample space, possible outcomes 1, 2, 3, 4, 5, 6. Correct? Next, if throwing a dice, each of the 6 numbers, maybe 1 will turns up, or 2 will turns up, or 3 will turns up, or 4 will turns up, or maybe 5, or maybe 6. Suppose 1 turns up, we have only one option, that is 1. 2 turns up, only one option, only 1, 2. 3 turns up, 4 turns up, again one option. 5, one option. 6, one option. Getting all 6 numbers are equally likely here. All 6 numbers, getting all equally likely are equally likely. Why? Because we'll getting a number only 1, we have only one option. Getting 2, only one option. Getting 3, one option. Getting 4, only 1 4, that is one option. Getting 5, one option. Getting 6, one option. Therefore, getting all 6 numbers are equally likely to show up the numbers 1, 2, 3, 4, 5. So these is called as, getting 6 numbers in the experiment throwing a die is also example for equally likely outcomes. Okay, is it clear? I shall continue next class.